Assalamualaikum warahmatullahi wabarakatuh. We are from Group H, and this is the group members. I am Nira. I will present the introduction and methodology for this assignment. For introduction, the MATLAB code provided is intended to simulate a particular piecewise function, ft where 0 less than t less than 2 and 2 less than t less than 4. Take the values 4.0 and negative 4.0 respectively. The code attempts to represent this alternating function pattern through sinusoidal components using Fourier series analysis. Using complex exponential and trigonometric forms, the process computes two types of Fourier series. These series are then shown to assess how similar they are to the original piecewise function across the designated time travels. With this method, the behavior of the supplied piecewise function is approximated by utilizing MATLAB's Fourier series analysis features. Next is methodology. Start the process begins. First, define the piecewise function ft. The function ft is defined as a piecewise function ft 4.0 for 0 less than t less than 2, ft negative 4.0 for 2 less than t less than 4. Initialize MATLAB variables. Parameters required for the Fourier series analysis are initialized. This include n, summation limit, w naught fundamental frequency, c naught, DC bias, and t time values. For compute Fourier series, two types of Fourier series are calculated. First, complex exponential form, YCE, second, trigonometric form, YT. Next, visualize results. Plots are created to visualize the original piecewise function with ft. Plots are created to visualize the original piecewise function ft and truncated Fourier series YCE and YT to compare with the original function. Analyze approximations, accuracy evaluation at the transition position, specifically T2, where the function changes its value. Comparison between the results are obtained from the complex exponential and trigonometric forms of the Fourier series. And the process concludes.
Assalamualaikum warahmatullahi wabarakatuh. I am Muhammad Amir Amran, EC21126, and today I am going to present the group assignment specifically about the design and calculation. So this is our design calculation. We are given, group H is given the amplitude of 4 and the predictive of 4. As we know, the square wave has its own formula, which is this one. And then the exponential Fourier series formula is this one. So when we plug in the numbers, this is what we get. This is the positive side, and this is the negative side. This is the sketch representation of the calculations, the amplitude spectrum and the phase spectrum. So this assignment is to visualize the Gibbs phenomenon, as you can see here. When n is equals to 5, we can see that the reconstructed wave is becoming more and more like the original wave. This is the amplitude spectrum and phase spectrum. We can see that it is when we compare it to the manual calculation, it is proven that our calculation is correct because 2.54648 is the same as 8 over pi, and so on with the other numbers. So and then next, I am going to demonstrate the usage of the code, which is I'm gonna use the initial number of 5 as I shown in the slide. So when n harmonic is equals to 5, we will get the same graph as the one shown in the slide. So what happens when we increase the n harmonics to more than just 5? So I'm going to demonstrate it. I'm going to choose n equals to 11 and I'm going to run it. So now we can see that when n equals to 11, the reconstructed waveform is getting closer and closer to the original waveform, and there will be more amplitude spectrum, and then there will be more phase spectrum on both the positive side and the negative side. So if you want to let's say make this reconstructed waveform perfectly as its original waveform, you can keep increasing the n harmonics. So in this case, I'm going to increase it 2 more times. Once the 111, and then the next one is 1111. As you can see, it is getting closer to the original waveform. Okay, so now the final iteration will be 1111. So once we use n harmonics equals to 1111, we can see that the reconstructed waveform is now similar, or it is exactly the same as the original waveform. So because the n harmonic is such a big number, MATLAB will take a little bit of time to calculate the amplitude spectrum and the phase spectrum. Okay, so this is the amplitude spectrum of n, harmonics of 1111, and phase spectrum is n harmonics 1111. I conclude my presentation and I'm going to hand it to the person next, which is going to discuss further about our assignment. Thank you.
My name is Amir Famrin Alisha. My number ID is EC21118. So I will explain about our discussion. For this, the coordinate successfully display the original piecewise function IT and its approximation in complex exponential and trigonometric form using truncated Fourier series. It is clear that the piecewise function is accurately represented by the Fourier series as approximation within the specified time interval. Nevertheless, more examination is required, especially at the spot where the function transition from 4 to -4. A comparison of the complex exponential form YCC and the trigonometric form YT show that they have different abilities to approximate the piecewise function. Any difference or limitation in the approximation should be identified. So that's all from me. I will pass to the Izzat Danish.
My name is Muhammad Izzat Danish bin Muhammad Zaidi. My ID number is EC21115. Okay, today I want to conclude our presentation. So for the conclusion is the behavior of the piecewise function ft within the specified time interval is correctly reproduced by the Fourier series analysis. The precision with which the approximation reproduce the value of 4 and -4 throughout the corresponding time interval show how effective Fourier series are at representing piecewise function. To ascertain the accuracy of this estimate, more investigation is necessary at the transition point t equal to 2, where the function change value. It is iterate how important Fourier series are for approximating complicated or piecewise function. Particularly in signal processing and engineering application, the accuracy of this approximation could be improved by suggestion for future improvement, including improving the Fourier series representation or assessing higher order approximation. To sum up the outcome produced by the MATLAB could provide insightful information about the Fourier series, approximation abilities for piecewise function. It demonstrates the series accuracy within predetermined interval and point out potential areas for further development at transition points. That's all from me. Thank you.